Hi. Woo! Unit 4 is over with. And I have some exciting news. I know everybody's going to be really excited about this. And that is, I now have Office 2016 on my computer. And since Office 2016 is much better than 2015, also known as takes up way much more space and way much more RAM, things are going to get even better on my computer, and I'm so excited. See it working. It's working great. So anyway, this is a little warm-up to day 0 or to day 1. A little prep work for when we start Unit 5, which is really exciting. All right, kids, so let's talk about this. We know what this is. We know what this is. Whenever you see this, it means you're going to have some kind of I in your problem. I think you better get the handle on that. I don't even know. That's not even a bad joke. So this is going to be 2 minus. What is the square root of negative 4? It is not negative 2. It's embarrassing. Whoever just said that, one of you just said it. I know you just said it. It's embarrassing. Totally embarrassing. Computer's sort of updating, so we'll see if we're going to crash. It took me longer just to get to this point than it's going to take to do this video. It's going to be a short video. It's just 2i. Plus, it is nicer that I can see my pen point there. Plus a negative 3, we're adding, right? Plus 4i. So now I just combine like terms. The 2 and the negative 3 make negative 1, and negative 2i and 4i make plus 2i. Notice it's in the real and the imaginary form, otherwise known as a plus a. Everything is updating. I don't need to update anymore. Get off my screen. You're killing me. There's the answer. All right, so let's keep moving. What is the sum of these? Now, this is a little bit easier. It's already set up, so I just add the real parts, which is 8, and I add the imaginary parts, which is negative 3i plus 2i, which is negative I. All right, so let's take back a little trip back to memory lane. And we're going to double distribute here. This is 6. That's easy. This is actually on your spiral this week, I think. These two things multiplied give me negative 12i. Maybe I should just move really slow. And then these are, and then these are, and then these are, and then these are and you say I don't need a new computer. Positive 3i. And then the hard part is this one right here. It's I times negative 6i, which is negative 6i squared. But you need to remember this big, huge fact over here. I squared is really negative 1. So this becomes 6. That's a 6. Wow, that is a lovely 6. It looks like a Roman number 3. And, you know, weight symbols. So 6. And there, we'll just go to 4 now. What the heck? 6. Minus, that's 9i, if I put those two together. And then this is negative 6, but this is negative 1. So negative 6 times negative 1 is positive 6. So these don't really hear. So I get 12 minus 9i. Wow, that was rather painful. Express the function transformation that occurred on this graph. So a couple things. This is a dilation. So it makes it wider or less steep. So wider or less steep. Basically, the rate of change is going to be slower. This minus 1 is a, come on, give me my pen, is a translation, otherwise known as a move right 1. Now, anytime you're going to add on 1, anytime you add on the inside like we're doing here, that is a move left or right. And remember, it's backwards. And this last part, this positive 3, that's a translation up 3 units. Ring a bell? All right, let's get to some news stuff. All right, here's some news stuff. Oh, well, no, actually, this is old stuff. I don't know why that's there. What we're going to do is, if you square this, I can rewrite it like this. Let me just show you the lame way to do this one. This one is going to be 2x cubed times 2x cubed, which is really 4x to the sixth. But that's kind of stupid to do that way, because what if that thing was like what if that exponent was like a 27? You wouldn't want to be doing that all day. That'd be dumb. So here's how it works. First thing we do is 2 squared. 2 squared is 4. And then you have to remember, when you have exponents raised to exponents, you multiply those exponents. So we're going to multiply them to get x to the 3 times 2, which is 6. That's it. That's all she wrote. All right, so when we're multiplying here, notice when we're multiplying and the bases are the same. Let me do that. Let me do it that way. Oops. When the bases are the same, so we have a and a, then all we have to do is add the exponents, and it gives me m plus 8. But the base stays the same. You don't change the base. So in this case, we've got 4 times 6. Let's just take care of that. That's 24. Notice this base and this base are the same. So it's going to be x, and then we add the exponents, x to the 7th. So if we add when we multiply, then when we divide, we are going to subtract. So again, as long as the bases are the same, you take the exponents, the m and the n, and you subtract them. So first we'll take care of the numbers. 80 divided by 20 is 4. And then what we end up with is x to the 10 minus 12, which is really equal to 4x to the negative 2. Wherein lies our problem? We don't ever, I can't speak. We don't ever really want to write something with negative exponents. Now, some of you probably would have done this problem this way. You would have said, okay, 20 goes into 84 times. And then the denominator has 2 more x's than the numerator. So really that would leave me x squared in the denominator. So how do these two things relate? How do these two things relate? Because they are in fact the exact same thing. They are in fact the exact same thing. And this little thing right here is going to cause some unbelievable confusion with my pupils. Not my eyes, my kitties. So let's talk about negative exponents. Let's talk about negative exponents, okay? What this translation, this is just a new rule. You need to learn this. If you have a negative exponent, what this is really equal to is, in this case, what you need to do is bring that to the denominator and make it positive. So this is really 1 over a to the positive m. Now, if you don't believe me, you should. Again, let's take a look at this. If I had x to the 5th over x to the 8th, this is really equal to, because remember, as long as the bases are the same, you subtract the exponent. This is really equal to x to the 5 minus 8, which is really equal to x to the negative 3. But most of you would not do it that way. Most of you would just say, hey, look, there's more x's in the denominator. How many more? 3. So we'll get rid of all of these. We'll get rid of all of these. We'll just not do anything because nothing's working. We'll just get rid of all of these. Leaves me 1 in the numerator. And we'll get rid of 5 of these. Leaves me 3 down here. So that's 1 over x cubed. Well, isn't that what I just said? When you have a negative exponent, you bring it to the denominator and make it positive. That's your rule. That's the new rule. New rule. So if I just have x to the negative 1, simply that is 1 over x. X to the positive 1, but I don't need to put that there. Now, you got to be careful. Check this out. This is really luckily, this is a short video. Otherwise, I might break something. Well, what I'm about to say is it's really 3 over 2 times x to the negative 5. Now, wait a second. It's supposed to be positive down there. If it's negative in the denominator, then it moves up. And it becomes positive up there. So 3 over 2. And then the x to the 5 comes to the top and becomes x to the positive 5. Now, why is that true? Well, let's take a look back. I'm going to put it over here. Hopefully, I got a little room for you. If you believe and trust in me that when we have x to the, let's say, negative 3, that's equal to 1 over x cubed. Then what you ought to believe then is if I have 1 over x to the negative 3, would you believe that this is really 1 over, now I'm just going to convert this, 1 over x to the positive 3. Now I'm going to erase this. Again, isn't this right here just this that I did up here? Yes. But what I said was we're going to start out with 1 over. So 1 over. So this thing is really this thing. Well, what happens when we divide by a fraction? We've been doing it a little bit. Let me erase this. We've been doing it a little bit in class. What I have here, let me rewrite this a little bit different. I'm going to write this a little bit different. What I have here is 1, the numerator, divided by 1 over x cubed. Well, when you divide by a fraction, don't you flip and multiply? So this thing really becomes 1 times x cubed over 1, but this is just x cubed, and 1 times x cubed is x cubed. So if you have a negative in the denominator, it really becomes in the numerator. Now, if I could write that over 1 if I wanted to. So let's take a look and see what we got here. You have to be careful of what's being raised to the negative exponent. In this case, the only thing being raised to the negative exponent is this 5x is being raised to the negative 2. So let me highlight it. This thing right here is going to come down to the denominator and become positive. So what I end up with is 3 over. Now this is going to get funky. 7 times 5x squared. Well, most of you know that 5x squared is really 25x squared. So if I replace this with a 25x squared, this really becomes 3 over 7 times 25 is 175x squared. Okay, that's kind of weird. So let's take a look at a few examples. Simply, the rule, here it is. It's 1 over a to the first, or just a. Here, again, they're in the denominator. They come to the numerator. So you end up with a to the positive 2 over 1, or just a squared. Here we got a little bit of both. This one's going up. This one's going down. So this really is a squared over a. Now, who has more a's? The numerator. How many more? 1. So we'll subtract 1 off there and subtract 1 off there, and I get a. Now, could I have just done this like this? A, since I'm dividing, can I just subtract these? I sure can. So that's negative 1 minus negative 2. Well, what is negative 1 minus negative 2? Well, what doesn't that minus really become a plus? So this becomes a to the negative 1 plus 2, which is a to the 1, which is what we did here. So you can do it either way. Okay, so here, be careful. The only thing being raised to the negative exponent is this. So this is really 3 minus 1 over a cubed. Now, if I had to combine that, I would have to make this one 3a cubed over a cubed minus 1 over a cubed. This would be 3a cubed minus 1 over a cubed. Not really sure I want to do that. Ooh, this one's kind of cool. Now this one's gonna. This is where things start getting a little bit funky, a little bit crazy. So I'm gonna highlight it. This is the only thing being raised to the next exponent. negative exponent, and so is that. So the 4, you'll notice this 4 does not have a negative exponent on it. And remember, exponents, man, I can almost speak. Exponents come before multiplication. So even though there's multiplication here, I have to take care of this piece first. So this really becomes 4 times 1 over a minus 1 over a squared. Or in other words, this becomes 4 over a minus 1 over a squared. And for now, let's just leave it like that. We'll talk about what you're going to do, how to simplify that later. Holy mackerel, this one's tough. So I'm going to write this a different way. I'm going to write this one as 1 over 5a all over 3 minus 1 over a squared. Now I'm going to combine the denominator. So I'm going to make this over 1. And so I'm going to make it so 1 over 5a, that's the numerator, all over 3a squared over a squared minus 1 over a squared. What you talking about, Willis? Look it up. Weird show. So this becomes 1 over 5a all over 3a squared minus 1 all over a squared. So now we have a fraction divided by a fraction. What are you talking about? Well, we're going to flip and multiply. We're going to take this and we're going to flip it and multiply it. A squared over 3a squared minus 1. So this a cancels with one of those a's, and it leaves me with a over 5 times 3a squared minus 1. That's just redunculous. So we're going to play around with these negative exponents. The biggest thing I want you to understand is negative exponents have nothing, N-O-T-H-I-N-G, nothing to do with being negative. Negative exponents, just take it from the top, throw it on the bottom, take it from the bottom, throw it on the top. And later on, we're going to work with fractions and negative exponents. Oh, it gets exciting. Oh my God, it's so exciting. Unit 5 is going to be so much fun because when we do long division, there's remainders. So you know how you got that 0 before? Now there's not going to be a 0. Oh no. You guys can handle it. You're rock stars. You're rocking this year. You're going to crank this year. I appreciate you guys as students. I hope this is the last video you have to watch before you get your Christmas presents and Santa's coming. Santa! I know him! Okay, that's it. I'm out. I didn't even have coffee tonight. Catch you guys on the flip side.